guys, welcome back to my channel, and today we're going to be learning about integers. So technically, what is an integer? You might be thinking. Any whole number that is greater than 0 is a positive integer. So there's 0 at a start point in the number line, and every number beyond it is a positive integer. Then whole numbers less than 0 are negative integer. So this time 0 is our endpoint, and every number on this side of it is a negative integer. For example, we have the start point is negative 5 and the end point is plus 5. So negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. That's one set of integers. Then integers can be represented evenly spaced points on a number line. So just imagine a line up above here, and these will all be like 1 centimeter apart from each other, and those points will have these numbers below it because they're evenly spaced, and so each negative integer is a mirror image of a positive integer with respect to the 0 mark. Now this is a 0 mark right here, or 0, and the mirror image of 1 minus 1 is 1, and same for the other integers. Then integer 0 is neither positive nor negative. It's special. Sometimes 1 is a unique number. It's not prime nor composite. Same for 0. It's neither positive nor negative. So examples of integer in real world applications. Now integers can be used in real life. Like Daniel owns $23. Mary earned $250. And the temperature in the freezer is 18 degrees Celsius below 0. Now, you might be wondering how. Let's take a look at the first one. Daniel owns $23. Now, owns means that you borrowed the money from someone, and then you have to give it back, like a bank loan or something. And that means if he has $100, he has to subtract 23 from it and give back to the person he did it from. Therefore, the answer to the question is negative $23. Now the next one. Mary earned $250. So earned means she's working and she got a salary of $250. Now that's a lot less than what people get, but okay. Now she has $100, she has $250 to it, and therefore the answer to the question is $250. Now the temperature in the freezer is 18 degrees Celsius below 0. Now we have a vertical number line, and 0 is right here. Now let's put it out 18. 18 below 0 is negative 18 right here. So therefore the answer to the question is negative 18 degrees Celsius. Now let's take a look at the properties of integers. Now the closure property, the associative property, the commutative property, the distributive property, and the identity property. Now the first one is the closure property. So among the various properties of integer, the closure property under addition and subtraction states that the sum or the difference of any two integers will always be an integer. So take any two integers, for example, x and y I have right here. And so for these two integers, x plus y and x minus y will also be an integer. So 3 plus 2, it is 3 plus 2 is 5. 5 is also an integer, and so is 3 and 2. Now 3 minus 2 is 1. 1 is also an integer, and so are 3 and 2. So this property states that any two integers, addition and subtraction will also give us an integer. Same for multiplication. Closure property for multiplication states that the product of any two integers will be an integer. Example, if x and y are two integers, x multiplied by y will also be an integer. So 5 times 6 is 30. 30 is an integer, and so are 5 and 6. Division of integers does not follow closure property. Now division can, sometimes the answer might be in point, which is not a whole number because it has a decimal in front of it. So the quotient of any two integers x and y may or may not be an integer. Moving on, the second property is the commutative property. So, the commutative property of addition and multiplication states that the order of terms does not matter. So, like, take any numbers and switch them around, you'll still get the same answer. The results will be the same, just like I said. Whether it's addition or multiplication, swapping of terms will not change the sum or the product. So, x plus y is equal to y plus x, and x multiplied by y is equal to y multiplied by x. By subtraction, x minus y is not equal to y minus x, and division, x divided by y is not equal to y divided by x, are not commutative for integers and whole numbers. The third property is associative property. So the associative property states that in addition and multiplication, the way of grouping numbers does not matter. The results will be the same. One can group numbers in any way they want, anyway. The answer will remain the same. Parentheses can be done irrespective of the order terms. So x plus open bracket y plus z is equal to open bracket x plus y close bracket plus z. Same for multiplication. Subtraction of integers is not associative in nature. For example, over here, so take any three numbers, put the last two in a bracket, and leave this one out. Now, try and do it with the same numbers, but put the first two in a bracket and leave the last one out. The answer will not be the same. The fourth property is the distributive property. Now, in addition and multiplication, I'm pretty sure every other thing, distributive property explains the distributing ability of operations over other mathematical operations within a bracket. It can be either distributive property of multiplication over addition, or distributive property of multiplication over subtraction. Sorry about that. Other integers can be added or subtracted first and then multiplied, or multiply first with each number within the bracket and then added or subtracted. This will be represented for any integer x, y, and z as x multiplied by y plus z is equal to x multiplied by y plus x multiplied by z. And over here for subtraction, x multiplied by y minus z is also x multiplied by y minus x multiplied by z. So the fifth one is the identity property. So this is the last one I'm going to be explaining today, and it's really easy. Amongst the various properties of integers, the additive property states that when an integer is added to 0, it gives the same number. 0 is called the additive identity for the integer. For any integer, x plus 0 is equal to x, and it's also equal to 0 plus x. So, yeah. The multiplicative identity property for integers says that whenever a number is multiplied by the number 1, it will give the integer itself. So 5 multiplied by 1 is 5. That's for an example. And therefore the integer 1 is called the multiplicative identity for a number. For any integer, x again, x multiplied by 1 is equal to x equal to 1 multiplied by x. And then if any integer is multiplied by 0, the product will be 0. X multiplied by 0 is 0, also equal to 0 multiplied by x. If any integer is multiplied by minus 1, the product will be the opposite number. So x multiplied by minus 1 is minus x, and minus x is also minus multiplied by x. So guys, that's it for today. Don't forget to like and subscribe to my channel, and see you guys next time. Bye!